So today we are going to study about plastids. This is another very important cell organelles found in plant cells. So this is very important to remember that this is absent in animal cell and is present only in plant cell. This is the one important difference between plant cell and animal cell. So plastid के हो इसको बारे में कुरा गरौँ. So plastids, like other cell organelles, is a cell organelles which is covered by a membrane. एउटा मेम्ब्रेनले कभर गरेको सेल मेम्ब्रेन सेल अर्गेनेल्स हो. जस्तो अरु धेरै सेल अर्गेनेल्सको वरिपरि मेम्ब्रेन हुन्छ. सो इट इज अल्सो बैग लाइक स्ट्रक्चर. यसलाई यसरी लेखौँ. इट इज अ बैग लाइक स्ट्रक्चर that contains pigment. Is a bag or a small pocket like a structure inside plant cell that contains pigment. Pigments means color. Cell भित्र रङहरु हुन्छ, pigmentsहरु हुन्छ, and these colors are kept inside a pocket inside cell, and this pocket within a cell is known as plastid if it contains pigments or color inside it. So depending on the different type of pigment stored inside it, there are basically three different types of plastids. Three types of plastids based on the color stored inside this bag. One very common is chloroplast. Next, chromoplast, and third one is leucoplast. In this way, there are three types of plastids: chloroplast, chromoplast, and leucoplast. So let's go in details of it, starting from the chloroplast. अब सबैको हामी अलिकति डिटेलमा स्टडी गर्न गइरहेछौँ, स्पेशली हामी क्लोरोप्लास्टको बढी डिटेलमा स्टडी गर्छौँ. नाउ व्हाट इज क्लोरोप्लास्ट? म त्यहीबाट सुरु गरेँ. Chloroplast. So it's a plastid. It is a plastid that contains green pigment inside it. यस्तो खालको प्लास्टिड जुन भित्र चाहिँ हरियो रङ बसेको हुन्छ अथवा हरियो रङको मोलिक्युल्सहरु, ग्रीन पिगमेन्ट्सको मोलिक्युल्सहरु बसेको हुन्छ, त्यस्तो खालको प्लास्टिडलाई क्लोरोप्लास्ट भनिन्छ. त्यो ग्रीन पिगमेन्टको नाम चाहिँ हामी नर्मली क्लोरोफिल भन्ने गर्छौं. क्लोरोफिल. Chlorophyll. So what is chloroplast and what is chlorophyll? अलिकति फरक छ, हामीले झुकिनु हुँदैन यसमा. So chloroplast is a plastid, is a bag like structure, and the pigment inside this chloroplast is called chlorophyll. So chlorophyll as a pigment is not a type of plastid, and this chlorophyll is found inside this bag known as chloroplast. So it is a plastid that contains chlorophyll inside it. So this is known as chloroplast. So chloroplast is commonly found in all green parts of the plants, mostly in the leaf. Mostly found in leaves, as well as in other green parts like green stem. कुनै कुनै प्लान्टको स्टेम पनि ग्रीन हुन्छ. स्पेशली सानो प्लान्टहरुको स्टेम हामी हेर्यो भने ग्रीन देख्छौं. त्यो ग्रीन भएको स्टेममा पनि क्लोरोप्लास्ट भन्ने प्लास्टिड हुन्छ. So mostly it is found in leaves. We know leaves are green in color. Why? Because they contain chloroplast, but this chloroplast is also present in the stem if it is green in color. So this is about where this chloroplast is found, means where chlorophyll is found. So अब यसको हामी स्ट्रक्चर पढ्न गइरहेका छौं. क्लोरोप्लास्ट को स्ट्रक्चर हामीलाई अलिक डिटेलमा पढ्नु पर्ने हुन्छ. अहिले मैले यहाँहरुलाई व्हाट इज क्लोरोप्लास्ट र यो कहाँ पाइन्छ भन्ने कुराहरु अलिकति छोटो गरी राखे यहाँहरुलाई. अब यहाँहरुलाई म स्ट्रक्चरको बारेमा कुरा गर्छु. अब त्योभन्दा अलिकति एउटा कुरा थपेँ मैले बिचमा कि क्लोरोप्लास्ट एउटा सेलमा कतिवटा हुन्छ भन्ने कुरा पनि हुनसक्छ. हाउ मेनी नम्बर अफ दिस क्लोरोप्लास्ट लाइक ब्याग आर प्रेजेन्ट इनसाइड सेल. एउटा सेलमा कति हुन्छ भनेर ठ्याक्कै भन्न सकिँदैन. एउटा मात्रै क्लोरोप्लास्ट पनि हुनसक्छ एउटा सेलमा, अनि धेरै क्लोरोप्लास्टहरू पनि हुनसक्छ. जस्तो कि कुनै ग्रिनहरू सम लिव्स आर डार्क ग्रीन इन कलर एन्ड सम लिव्स आर लाइट ग्रीन इन कलर बिकज अफ द नम्बर अफ क्लोरोप्लास्ट. हामी देख्छौँ कुनै एकदम हरियो लिफ, त्यसमा त्यो लिफको सेलमा हेऱ्यो भने चाहिँ थोरै क्लोरोप्लास्ट हुनसक्छ. अलि हल्का हल्का ग्रीन कलरको लिफमा हेऱ्यो भने अलिक बढी क्लोरोप्लास्टको नम्बरहरू हुनसक्छ एउटै सेलभित्र. दिस इज हाउ द नम्बर भेराइज. ओके, नम्बर भेराइज. नम्बर कति हुन्छ भनेर वी क्यानट. सो हामी नम्बरको कुरा गर्दै थियौँ. नम्बर कति हुन्छ क्लोरोप्लास्ट भन्दाखेरि इट भेराइज ग्रेटली. इट मे बी 1 to many. फर इक्जाम्पल, इफ यु सी द नम्बर अफ क्लोरोप्लास्ट इनसाइड क्लामाइडोमोनास, त्यहाँ एउटा मात्रै हुन्छ, 1 single क्लोरोप्लास्ट इनसाइड क्लामाइडोमोनास, बट इट मे बी मोर देन 1000 पनि हुनसक्छ विदिन अ सिंगल सेल. सो नम्बर ग्रेटली भेराइज, मे बी 1 to many. 1 to many. अलिकति सेपको बारेमा पनि म यहाँहरूलाई बताइदिइहाल्छु. हाउ इज द सेप अफ क्लोरोप्लास्ट. क्लोरोप्लास्ट भन्ने ब्याग द्याट कन्टेन्स क्लोरोफिल, यसको स्ट्रक्चर कस्तो हुन्छ, सेलभित्र यो प्लास्टिडको स्ट्रक्चर कस्तो हुन्छ. सो सेप लाइक नम्बर, सेप अल्सो भेराइज. सेप भेराइज. देयर इज नो डेफिनेट सेप अफ क्लोरोप्लास्ट. ठ्याक्कै यस्तै हुन्छ भनेर मान्न सकिँदैन. कुनै प्लान्टको सेलमा हेऱ्यो भने एक खालको सेप देखिन्छ क्लोरोप्लास्टको, अर्को प्लान्टको सेलमा हेऱ्यो भने अर्को खालको सेप देखिन सक्छ. सो सेप यस्तै हुन्छ भने सर मोस्टली इट इज ओभल इन सेप. मोस्टली ओभल इन सेप. ओभल सेपको हुन्छ, तर नहुन पनि सक्छ. धेरैमा चाहिँ ओभल सेपको हुन्छ. अब यो मोस्टली हामीले हेऱ्यो भने के एक्जाम्पल हेऱ्यो भने, फर इक्जाम्पल भेरी कमन एक्जाम्पल अफ एल्गी इज स्पाइरोगाइरा, जहाँ क्लोरोप्लास्टको सेप रिबन सेपको हुन्छ. फर इक्जाम्पल मैले ओभल सेपको हुन्छ भने, तर इफ यु सी द क्लोरोप्लास्ट इन स्पाइरोगाइरा, सेल्स अफ द स्पाइरोगाइरा, इट इज स्पाइरली कोइल्ड. यसलाई मैले यसरी लेखेँ, स्पाइरल सेप. स्पाइरल सेप इन स्पाइरो, CYRA. Spiral ribbon shape. Spiral shape in Spirogyra. It is cup shape in Chlamydomonas. मैले दुईटा एल्गीको नाम लेखेँ, स्पाइरोगाइरा, क्लामाइडोमोनास. यो दुईटै एल्गी हुन्. जस्तै स्पाइरोगाइरामा हेऱ्यो भने स्पाइरली कोइल्ड रिबन सेपको हुन्छ, र क्लामाइडोमोनासमा हेऱ्यो भने कप सेपको हुन्छ. स्पाइरल रिबन सेप एन्ड कप सेप भन्ने यो मात्रै होइन, अरू धेरै सेप्सहरू पनि हुन्छ, बट मोस्टली दे आर ओभल इन सेप. दिस इज द मोस्ट कमन टाइप अफ द सेप फाउन्ड इन क्लोरोप्लास्ट. अब यहाँहरूलाई म स्ट्रक्चर अफ क्लोरोप्लास्टको बारेमा डिटेलमा कुरा गर्न गइरहेको छु. सो अहिलेसम्म हामीले वाट इज क्लोरोप्लास्ट, वाट इट इज फाउन्ड, वाट इज द नम्बर अफ क्लोरोप्लास्ट इन इच सेल, एन्ड हाउ इज द सेप, यसको बारेमा एकदम छोटकरीमा कुरा गऱ्यौँ. यसमा धेरै भेरिएसनहरू छ. सो नाउ अब हामी क्लोरोप्लास्टको स्ट्रक्चरको बारेमा कुरा गर्न गइरहेका छौँ. So now let's talk about the functions of the chloroplast. What is the role of chloroplast? Why chloroplast is necessary? So chloroplast is a bag or the structure inside cell, plant cell, where process of photosynthesis occurs. So this is the most important function. It is the site of photosynthesis. That's why it is also called kitchen of the cell, commonly known as kitchen of the cell. Commonly known as kitchen of the cell. Why? Because food making process occurs inside chloroplast. That's why it is called kitchen of the cell. So chloroplast is a bag that contains chlorophyll. That's why the process of photosynthesis occurs inside the chloroplast. That's why it is the site of photosynthesis. Food making process occurs here. Chloroplast is the structure where photosynthesis occurs, and because of photosynthesis, we get oxygen. So by the process of photosynthesis, plant releases oxygen, which is most vital gases for the survival of all living beings. So chloroplast helps to release oxygen and absorb carbon dioxide. These two are the important gases which are extant during photosynthesis. This carbon dioxide is absorbed inside the plant for the photosynthesis process, and during the process oxygen is released in the atmosphere, and this oxygen is utilized by all living beings. That's why. So this chloroplast is necessary. Why? Because of the chloroplast, oxygen is released and the carbon dioxide is absorbed. So because of this absorption of carbon dioxide from atmospheres, chloroplast helps in. It helps in reducing global warming. So global warming, I think you are familiar with this. What is global warming? The temperature of the earth is rising year after year because of the production of different type of gases, especially carbon dioxide. Excess amount of carbon dioxide in the atmosphere increases the temperature of the earth, which is called global warming. But because of chloroplast, this excess amount of carbon dioxide is absorbed. That's why chloroplast helps to control the percentage or the level of the carbon dioxide in the atmosphere. That's why it reduces global warming. So another very important function of the chloroplast, all this greenery in the nature, we see all around us green color. We see a mountain, this is green. We see a grassland, this is also green. We see a forest, this is also green. This natural greenery, or the beauty of the nature, which is because of green color, is because of chloroplast. Since chloroplast is present inside the cells of the plant appears green. That's why the nature, the most of the part of the nature appears green. So the natural beauty or the greenery of the nature is also because of chloroplast. Greenery of nature is also due to chloroplast. So these are some important functions of the chloroplast, but the most important function is the site of photosynthesis. And this photosynthesis, let's elaborate these things. Photosynthesis is completed in two distinct phases. One is light reaction and another is dark reaction. The whole process of the mechanism of photosynthesis is divided into two. Light reaction, first half of the photosynthesis, and this dark reaction, this is the second half of the photosynthesis. In this process, to complete this first half, light is essential, and to complete this second half, light is not necessary. That's why it is called dark reaction, where the light is not necessary. To complete this first half of the photosynthesis, which is called light reaction, light is necessary. Anyway, so in this way, photosynthesis is divided into two phases, light reaction phase and the dark reaction phase. This light reaction phase of photosynthesis occurs in thylakoid membrane. Thylakoid membrane. And the dark reaction, the second half of the photosynthesis, this process occurs in stroma. Stroma means fluid. Okay. That's why chloroplast is the site of photosynthesis, where light reaction and the dark reaction occurs. So here I have shown where light reaction occurs inside the chloroplast, where dark reaction occurs in the chloroplast. So now I'm going to talk about the chromoplast. What is chromoplast? So from the classification of the plastid, you can understand what is chromoplast. It's a type of plastid. But what type of plastid is called chromoplast? कस्तो हुन्छ chromoplast भने कस्तो खालको plastid हो यसको बारेमा हामी कुरा गर्छौं. So we can define it in this way. It is a type of plastid that contains pigment. Pigment means color. Other than green. If the green pigment is found inside a plastid, then the plastid becomes chloroplast. If other types of pigments other than green are found inside the plastid, then this plastid is called chromoplast. So chromoplast is a type of plastid where different type of pigments are found except green. So where it is found, this is very important. So let's talk about where this chloroplast found inside plant. This chloroplast, it contains various type of the colors or pigment. It is mostly found in the color parts of the plants. The parts of the plant which are color like fruits. Different type of fruits have different colors, like different type of flowers which are very much colored. So this colored portion of the plant contains this chromoplast. So it is found in like flowers, fruits, etc. So यस्तो पार्ट्सहरुमा हामी हेर्यौं भने त्यहाँको सेलमा चाहिँ क्लोरोप्लास्ट नभएर क्रोमोप्लास्ट हुन सक्छ. सो अब यो यसको अलिकति हामी स्ट्रक्चरको कुरा गर्छौं, एकदम छोटो. हाउ इज द स्ट्रक्चर अफ द क्लोरोप्लास्ट? Chromoplast. Like chloroplast, this chromoplast is also double membrane structure covered by two membrane, outer and inner membrane. But one important difference in between chloroplast and chromoplast is inside chromoplast we can see this layer like structure known as the granum, and this structure granum is absent inside chromoplast. एकदम सर्टकटमा यसरी लेख्छु म. It is double membrane plastid without granum. Granum भित्र हुँदैन, थाइलाकोइड मेम्ब्रेन्सहरु यस भित्र हुँदैन. स्ट्रक्चर चाहिँ हेर्यो भने क्लोरोप्लास्ट जस्तै हुन्छ, तर अलिकति बढी यो इलाङ्गेटेड. इट इज मोर इलाङ्गेटेड अर एंगुलर. It is more angular or needle shape. सेलमा हेर्यो भने यसको शेप चाहिँ अलिकति लाम्चो खालको हुन्छ, एकदम ओभल जस्तो हुँदैन, अलिक बढी यो एंगुलर हुन्छ एन्ड needle shape को हुन्छ. So this is about the chromoplast structure. Now there are different type of chromoplast. Chromoplast को टाइपहरु छ. Why? Because chromoplast contain different type of pigment inside it, and what type of pigment is found. So based on the pigment found inside this chromoplast. So chromoplast are grouped into two. Mainly there are two main types of the chromoplast. Two main types. One is pheoplast, and next is rhodoplast. RHODO, rhodoplast. This pheoplast and rhodoplast are the type of chromoplast. And this pheoplast is a type of chromoplast which contains brown pigment. It contains brown pigment. Like, for example, fucoxanthin. Fucoxanthin is a name of pigment which gives brown color to the parts. That's why this fucoxanthin pigment is found inside of chromoplast, and this chromoplast is known as pheoplast if it contains brown pigment like fucoxanthin. Likewise, rhodoplast, it contains red pigment. Like, for example, phycoerythrin. So phycoerythrin is a pigment which gives a red color to the parts. So this phycoerythrin pigment is not found inside chloroplast. This phycoerythrin is found inside chromoplast called rhodoplast. Likewise, fucoxanthin is also pigment which is not found inside chloroplast, while it is brown in color. And this fucoxanthin is found inside chromoplast, known as pheoplast. So these are the two important type of chromoplast. One containing brown pigment known as pheoplast, another containing red pigment called rhodoplast. So let's see the function of chromoplast. Functions. What are the functions of chromoplast? So since it gives different color to the different parts like flower and fruit, so its main function is to help in pollination by attracting insects and birds. Why? Because of the color, insects and birds are attracted in plants, and because of the visit of different type of insects and birds, they help in pollination process. So this is the main function of chromoplast, helps in pollination. Helps in pollination by attracting insects and birds. This is about the chromoplast. So now let's talk about the last type of the plast known as leucoplast. अब म यहाँहरुलाई ल्युकोप्लास्टको बारेमा केही जानकारी दिन्छु. So what is leucoplast? So it's a type of plastid, very simple, which is colorless. Type of plastid which is colorless. Actually, colorless means white pigment. The type of plastid which contains white pigment inside it is known as leucoplast. So white color is generally considered as colorless. So we can define it this way: it is a type of plastid which is colorless or which contains white pigment. So it is found mostly in the plant parts which are colorless or white in color. No green pigment, no other pigments. So whereas other pigments like green and other like fucoxanthin or phycoerythrin, such pigments are absent, then this portion contains cells where leucoplasts are present. Means mostly it is found in colorless portion of the plants, mostly in the white color portion of the plants. Example, roots. So cells of the root mostly contain leucoplast because roots are mostly colorless or white in color. So type of leucoplast. There are different type of leucoplast which are found in non-colored portion of the plant. So type of leucoplast based on the material stored inside it. What is the main function of leucoplast? The answer is leucoplast helps in storage of food. So this is the types of leucoplast I am going to describe here based on the food stored inside the leucoplast. Based on stored food. What type of food is stored inside this leucoplast? Based on the type of food is stored inside it, leucoplast are of three types. Amyloplast is a type of leucoplast where food is stored in the form of carbohydrate. Stores carbohydrate. Another type of leucoplast is eleuronplast. is a type of leucoplast where food is stored in the form of protein. So, a leuronplast is a leucoplast that stores food in the form of protein. It's also called proteineoplast. A leuronplast or proteineoplast. So, the third type of leucoplast is eleioplast. Eleioplast is a type of leucoplast that stores food in the form of lipid. Lipid means fat, oil, etc. Fats, oils. If the food is stored in the form of oils, fat, inside a leucoplast, then this leucoplast is called eleioplast. It's a type of leucoplast. A leuronplast is also a type of leucoplast where food is stored in the form of protein. Likewise, a myeloplast that stores food in the form of carbohydrate. In this way, there are three types of leucoplast. So, what is the function of leucoplast? It's shown here. It helps in the storage of food. So, function. From the classification of this leucoplast, we can understand what is the main function. Helps in storage of food. This is the function of leucoplast. Leucoplast may be converted into chloroplast in presence of light. So this is called conversion of one type of the plastid into another type of plastid. Leucoplast, let's say leucoplast on exposure to light may be converted into chloroplast on exposure to light. So from this you can understand one type of plastid is converted into another type of plastid. Leucoplast is converted into chloroplast. Likewise, the chloroplast is also converted into, let's see, chloroplast. It's converted into chromoplast. So here I have shown how one type of plastid is converted into another type of plastid. Leucoplast is converted into chloroplast, and the chloroplast is converted into chromoplast. For example, let's see the example. One example of is leucoplast. How leucoplast is converted into chloroplast. So you might have seen potato. Potato generally they are white in color or slightly yellowish in color. If you cut any potato and see the structure or the color of this potato piece inside it, then they are mostly whitish or slightly yellowish in color. Why? Because the cells in this potato contains leucoplast. But while growing on the ground, on the soil, if this potato comes above the level of the soil and become exposed to sunlight, then the portion of the potato that lies above the soil becomes greenish in color. You might have observed some potato while cutting different potatoes. You might have seen greenish color on the surface of potato because of the conversion of leucoplast into chlorophyll. Let's say let's suppose this is what soil surface, and this is, let's say this is one potato growing on the surface of growing in the soil is completely inside. Let's say this potato is completely inside, but while growing in the soil, if this potato comes above the surface of the soil and exposed to the sunlight, and then this portion of this potato which contains leucoplast, the portion of the potato which contains leucoplast at the beginning now becomes chloroplast, becomes greenish in color. This portion may become green. This is because of the conversion of leucoplast into chloroplast. So this is the example of conversion of leucoplast into chloroplast. So likewise, chloroplast may be converted into chromoplast. You might have seen, let's say, green papaya later on becomes yellowish papaya. Likewise, you might have seen a green mango later on becomes yellow mango. Conversion of chloroplast into chromoplast. Very simple example is green tomato. Let's say green tomato. Green tomato becomes a red tomato. Red tomato. Green tomato contains chloroplast, that's why it is green in color. But with the growth, this green tomato becomes a red tomato, and the chloroplast inside the green tomato now converted into chromoplast. That's why later on the tomato becomes red because of the conversion. So this shows the example how one type of the plastid is converted into another type of plastid. So that's all about the different type of plastid. So now I'm going to talk about another cell organelles known as endoplasmic reticulum. In shortcut, it is called ER. So this is very important cell organelles which is found only in the eukaryotic cell. So it is absent in prokaryotic cell. Then now let's say what is endoplasmic reticulum. So if you draw the structure of cell, let's say this is a plant cell. Let's say small plant cell. Let's suppose this is nucleus. So you might have drawn the structure or the figure of plant cell or animal cell. So while drawing the figure of plant cell and animal cell, you might have drawn the structure like this. This is called endoplasmic reticulum. Let's say this is cell membrane. Cell membrane lies here, so associated with cell wall also. This is cytoplasm. Let's say this is cytoplasm. This is endoplasmic reticulum. So you can draw the structure here also. Several such structure, highly folded structure is connected to the nuclear membrane, mainly to the nuclear membrane, but also associated with cell membrane. Sometimes they are also connected with the cell membrane, or also found freely in the cytoplasm also. Okay, all these are the structure what I've drawn except this nucleus. All this structure represent endoplasmic reticulum. So then from this structure you can understand what is endoplasmic reticulum, or you can define this word endoplasmic reticulum, then it gives the definition of endoplasmic reticulum. So endoplasmic reticulum. So try to understand these two words. What is endoplasmic? What is reticulum? Endoplasmic means the cytoplasm which lies closer to nucleus. The portion of the cytoplasm which is found around the nucleus is called endoplasm, and the portion of the cytoplasm which lies away from the nucleus, let's say towards the cell membrane, towards this side, this portion of, so if you can analyze these two different words, what is endoplasmic, what is reticulum, then you can understand what is endoplasmic reticulum. So endoplasmic means the cytoplasm which is found closer to nucleus. Nucleus को वरिपरि पाइने साइटोप्लाज्मलाई छेउछेउमा पाइने साइटोप्लाज्मलाई एन्डोप्लाज्म भन्छ. अलिक टाढा टाढा सेल मेम्ब्रेनतिर पाइने साइटोप्लाज्मलाई एक्टोप्लाज्म भन्छ. So this structure that we are going to talk, ER, is mostly located closer to nucleus in the endoplasm. That's why it is called endoplasmic. Now a reticulum, what is the meaning of reticulum? So reticulum means it indicates a highly connected interwoven structure. That's why endoplasmic reticulum is network-like structure. You can say highly connected or interconnected structure, highly folded structure. This is endoplasmic reticulum. So you can define endoplasmic reticulum in this way. It is a type of cell organelles which is highly folded and membranous and forms network like structure. अहिले यहाँ केही कुराहरु what is endoplasmic reticulum त्यसको बारेमा लेखेँ. It is a type of cell organelles which is highly folded and membranous and forms a network like structure. It's a membrane, you can see it is a membrane. So let's suppose this is a straight membrane. When it is folded in this way, then the structure looks like this, and this is called endoplasmic reticulum. Actually it is a membrane. membrane, but the highly folded membrane. So many foldings are, you can see here, you can see number of foldings in this way. A membrane is folded and forms highly connected or the highly interwoven structure, which is called endoplasmic reticulum. So if you see the structure of the endoplasmic reticulum, it consists of three different parts. Three parts of the endoplasmic reticulum. Three parts. One is cisternae, another second vesicle, and tubules. These three are the structure, different parts of endoplasmic reticulum. So if you see the structure of cisternae, then it looks like this long tube-like structure. Long tube-like structure with this small dot-like structure known as ribosome on its surface. This is called cisternae. Cisternae is tube-like, but it is not branched. It is unbranched tube-like structure that bears ribosome on its surface. Let's suppose this is ribosomes. Several ribosomes are found on the surface of cisternae, part of the endoplasmic reticulum. And if you see the structure of the vesicles, then vesicles appears like this. Oval or rounded in shape. It is not tube-like structure, it is more or less oval or round in shape without ribosome on its surface. And the tubules are also tube-like structure, but these are highly branched in this way. Let's suppose you can see highly branched structure. Tube, but it is branched, but without ribosome on its surface. So these two, vesicle and the tubules, lacks ribosome on the surface, and the cisternae portion of the endoplasmic reticulum contains ribosome on its surface. And the type of ribosome which is found on the surface of endoplasmic reticulum is ATS type. ATS type. There are two types of ribosome, 70 and ATS type. And the ATS type is found on the surface of endoplasmic reticulum. Okay, these three are the main parts of the endoplasmic reticulum. These structures, these cisternae, vesicles, and these tubules are freely floating in this cytoplasm. This fluid inside the cell is called cytoplasm. Let's suppose this is what cisternae. Let's say this is cisternae. It contains ribosome on its surface. Let's suppose this one is vesicles. And let's say this one is what, tubules. Let's see. So I have drawn here all these three parts. This is vesicle, this is what cisternae, and this is tubules. Number of vesicles, number of the cisternae and these tubules are freely floating in this cytoplasm. अब म यहाँलाई endoplasmic reticulum को काम के हो अथवा धेरै सेलहरुमा यूकेरियोटिक सेलहरुमा endoplasmic reticulum हुन्छ, किन सेललाई endoplasmic reticulum चाहियो, यसको बारेमा कुरा गर्छ. What are the roles or the functions of ER? Number one, since ER is itself a membrane, but it is folded membrane as a structure, that's why this ER is utilized to make this structure like cell membrane or the nuclear membrane or the membrane around the mitochondria or chloroplast. All these different membranous structures which are found in cell are made by endoplasmic reticulum. That's why it is called membrane factory of the cell. Helps to make different membranes in cell, like cell membrane, like nuclear membrane, or membrane of mitochondria or chloroplast. Is सबै membraneहरु यसैबाट बनेको हुन्छ. That's why it is called commonly known as membrane factory of the cell. See, so since this endoplasmic reticulum makes a highly connected dense network in the cytoplasm, so it functions like the skeleton. like skeleton is spread inside our body. So when you touch the different parts, then we see the skeleton inside it. Likewise, this endoplasmic reticulum is spread throughout the cytoplasm and it functions like the skeleton of the cell. So that's why it is called cytoskeleton. So that's why it helps to maintain the support. It gives support to the cells, provides mechanical support. Provides mechanical support. Provides mechanical support to cell. That's why it is called, that's why it is also called skeleton of cells. Also called skeleton of cell. Why? It functions like the skeleton, gives support to the different structures inside the cell. For example, अब ये साइटोप्लाज्ममा माइटोकन्ड्रिया, क्लोरोप्लास्ट, गोल्गी बडी अरु धेरै सेल अर्गेनेल्स, राइबोसोम सबै फ्लोट गरिराखेको हुन्छ। ती सबलाई अड्याउने ठाउँ अथवा ती सब बस्ने ठाउँ भनेको त्यो नेटवर्क जालो जस्तोमा बसिराखेको हुन्छ। So it gives support to mechanical support to different cell organelles of the cells. So provides mechanical support to cell means cell organelles. So another very important, it helps in the transportation of materials from one part of the cell to another part of the cells. So it is highly folded like structure. You can see a channel-like structures. Through this channel, materials within the cell circulate from one portion of the cell to another portion of the cell. And it also helps in the transportation of the materials from cell to outside. So that's why it is also known as the cell circulatory system. Why? Because like circulate the materials within our body. Here, endoplasmic reticulum circulate the materials within the cell or from cell to outside the cell. So it helps in circulation material. Intracellular or intercellular circulation. Intra means within the cell or intercellular. So another very important function of ER ko euta kaam ke cha bhane, so it helps in the formation of primary lysosomes, also helps in the formation of cell plate and recycling of cell membrane. मैले त्यो तीनटालाई एकै ठाउँ जोडेर लेखेँ. It helps in the formation of primary lysosomes, cell plate, etc. Also helps in recycling or regeneration of cell membrane. So cell membrane is the living structure inside the cell. So if any injury or cut occurs or if any damage occurs in the cell membrane, then it gets repaired. And to repair the cell membrane, so cell membrane needs some extra membrane to patch up this damage. So this extra membrane is provided by endoplasmic reticulum. In this way, ER also helps in the regeneration or the recycling or repairing of the cell membrane. Likewise, this ER also helps in the formation of primary lysosome. This is one very important cell organelle. Also helps in the cell plate. Cell plate is the beginning structure of the cell wall. So the material to make cell walls are transported by endoplasmic reticulum. So finally, एउटा कुरा लास्टमा गर्छु. सेल भित्र भएका टक्सिनहरुलाई डिटक्सिफाई गर्ने काम पनि एन्डोप्लाज्मिक रेटिकुलमले गर्छ. डिटक्सिफाई गर्नु भनेको न्यूट्रलाइज गर्ने. अब टक्सिनलाई न्यूट्रलाइज गर्नु भनेको टक्सिन भनेको विष जस्तो चीज हो. These are the poisonous things which damage or which kills the cell. And if any poisonous things comes in contact with the cell or enters within the cell, then these are neutralized by the substance produced by endoplasmic reticulum. So helps in detoxification. Detoxification of toxin. That's it. Okay. These are some important functions of the endoplasmic reticulum. So mainly it helps in the formation of the different membranes in the cell. So this is the main functions. So beside this, it also helps in what circulation of the material. So these are the very important functions. So there are so many other functions, but here I have shown one very important functions of the endoplasmic reticulum. अब म यहाँलाई सेल थ्योरीको बारेमा छोटो कुरा गर्छु. व्हाट इज सेल थ्योरी र यो सेल थ्योरी भनेको के हो यसको बारेमा कुरा गर्छु. सो सेल थ्योरी भनेको सेलका केही कुराहरू पत्ता लगाइसकेपछि सेल के हो, यो कस्तो हुन्छ, यो यहाँभित्र के कुराहरू पर्छन् भन्ने कुराहरूको बारेमा पहिलोचोटि दुईजना साइन्टिस्टहरूले केही पोइन्ट्सहरू बनाउनु भयो जसलाई हामी सेल थ्योरी भन्छौँ, जुन चाहिँ सेलको बारेमा पहिलोचोटि भनिएका कुराहरू हुन्. त्यसैलाई आज हामी सेल थ्योरी भन्छौँ. सो सेल थ्योरी वाज given by Schledian and SCHWANN in the year 1839 AD. In the year 1839 AD, Schledian and so on, these two scientists jointly proposed cell theory. उनीहरूले सेलको बारेमा त्योभन्दा अगाडि 1839 भन्दा अगाडि के कुराहरू सेलको बारेमा पत्ता लगाए, त्यसको आधारमा सेलको बारेमा केही उनीहरूले पोइन्ट्सहरू बनाए, सेल यस्तो हुन्छ उस्तो हुन्छ भनेर. त्यसैलाई हामी सेल थ्योरी भन्ने गर्छौँ. त्यसका केही मेन बुलेट्सहरू अथवा केही मेन पोइन्ट्सहरू म यहाँलाई देखाउँछु. सम इम्पोर्टेन्ट पोइन्ट्स. जस्तो हामी अहिले भन्छौँ एभ्री लिभिङ बिङ इज मेड बाई सेल. त्यो कुरा सेल थ्योरीको एउटा पोइन्ट हो. त्यसलाई यहाँ लेखौँ हामी. यो अहिले हेर्दाखेरि एकदम सिम्पल पोइन्ट जस्तो लाग्छ, तर यो सुरुमा चोटि कसले भन्यो भन्दाखेरि यो दुईजना साइन्टिस्टहरूले भन्नुभएको थियो. सो अल लिभिङ्स आर मेड बाई cells. Cell is structural and functional unit of life. यो सेकेन्ड पोइन्ट भयो. हरेक सेलको स्ट्रक्चर हुन्छ, हरेक सेलले काम गर्छ. स्ट्रक्चरल एन्ड फङ्सनल युनिट अफ लाइफ. जुनसुकै अर्को एउटा पोइन्ट थप्छु यहाँ. सो जुनसुकै सेल छ भने पनि हरेक सेलको चाहे प्लान्टको होस्, चाहे एनिमलको होस्, अथवा कुनै एउटा बर्ड्सको अथवा कुनै एउटा अर्थमको कुनै पनि लिभिङ बिङको सेलहरू भने त्यहाँभित्र पाइने बेसिक कम्पोनेन्ट्सहरू अथवा मेटेरियल्स जुन सेलभित्र पाइन्छ त्यो चाहिँ लगभग मिल्छ. ठ्याक्कै चाहिँ मिल्न सक्दैन, तर बेसिक अथवा फन्डामेन्टल थिङ्स विच आर फाउन्ड इनसाइड द सेल्स आर कमन इन अल लिभिङ बिङ्स. Fundamental structure and chemicals. Chemical composition of all cells of living being is similar. एक्ज्याक्टली सिमिलर चाहिँ हुँदैन. जस्तै कि फन्डामेन्टल भन्ने लेखेँ मैले. फन्डामेन्टलको बेसिक स्ट्रक्चर र त्यहाँभित्र पाइने केमिकल्सहरू अफ अल सेल्स अफ लिभिङ बिङ्स इज सिमिलर. जुनसुकै लिभिङ बिङको पनि जुनसुकै सेल हेऱ्यो भने पनि त्यहाँभित्र पाइने स्ट्रक्चर र केमिकल्सहरू चाहिँ लगभग मिलेको पाइन्छ. केमिकल कम्पोजिसनमा केही फरक होला, स्ट्रक्चर केही फरक होला, तर बेसिक त्यहाँ मेन जुन पाइनै पर्ने कुरा हो त्यो चाहिँ सबै सेलहरूमा पाइन्छ. सो यो भयो सेल थ्योरीका केही बेसिक पोइन्ट्सहरू भयो. त्यस्तै अब अर्को एउटा पोइन्ट छ, जस्तो कि हामी भन्छौँ सेल्स आर टोटिपोटेन्ट भन्छु, एउटा सेलले अर्को सेल बनाउँछ भन्ने कुरा छ। त्यसलाई पनि हामी एउटा पोइन्ट्सको रूपमा लेख्न सक्छौँ। सेल्स आर टोटिपोटेन्ट, सेल्स आर टोटिपोटेन्ट। सेल्स आर टोटिपोटेन्ट भनेको सेल हेज क्यापेसिटी टु प्रोड्युस अनदर सेल्स। हरेक सेलले अर्को नयाँ सेल बनाउन सक्छ अथवा त्यही सेलबाट नयाँ होल अर्गानिजम पनि बन्न सक्छ। त्यसैलाई हामी टोटिपोटेन्ट भन्छ। यसको कुरा अहिले फेरि हामी गरौँला। सेल्स आर टोटिपोटेन्ट। यसलाई हामी अर्को पोइन्टको रूपमा लेख्न सक्छौँ। एउटा सेल थ्योरीको अर्को एउटा पोइन्ट के भने all living cells contains one nucleus। हरेक सेलमा एउटा न्युक्लियस चाहिँ हुन्छ भन्छ सेल थ्योरीको एउटा फन्डामेन्टल एस्पेक्ट। अरू धेरै पोइन्ट्सहरू हुन्छ नि, अब सबै कुराहरू यहाँ हामी मेन्सन गर्न सक्दैनौँ। मैले केही बेसिक पोइन्ट्सहरू यहाँहरूको सामु राखेँ। सो दिज आर सेल थ्योरी, दिज आर द पोइन्ट्स अफ सेल थ्योरी। अब म यहाँलाई गोल्गी बडीको फङ्सन्सको बारेमा कुरा गर्छु। सो वाट आर द इम्पोर्टेन्ट रोल्स अफ गोल्गी बडी इन सेल, के काम गर्छ गोल्गी बडीले, यसको बारेमा कुरा गर्छु। सो द मोस्ट इम्पोर्टेन्ट फङ्सन्स जो अघि मैले बताइसकेँ, इट इज अ कलेक्सन अफ ब्याग, इट इज अ ग्रुप अफ ब्याग। अब ब्याग भन्ने बित्तिकै इट हेल्प्स इन द स्टोरेज, के स्टोर गर्छ भन्ने कुरा भयो। यसले आफै एकैचोटि स्टोर त गर्दैन, इट स्टोर द डिफ्रेन्ट सब्सटेन्स प्रोड्युस बाई अदर डिफ्रेन्ट सेल अर्गेनल्स। जस्तै कि मेनली द मेटेरियल्स प्रोड्युस बाई इन्डोप्लाज्मिक रेटिकुलम्स आर स्टोर्ड इनसाइड द गोल्गी बडी एन्ड देन फाइनली ट्रान्सपोर्ट गर्ने काम हुन्छ। सो त्यसैलाई म समराइज गरेर एउटा फङ्सन लेख्छु। इट हेल्प्स इन collection, storage, modification, then packing, and finally transportation of cellular material। मैले यहाँ धेरै कुरालाई समराइज गरेर एउटै सेन्टेन्समा व्हाट इज द फङ्सन अफ गोल्गी बडी। इट हेल्प्स इन कलेक्सन, के को कलेक्सन भन्दाखेरि डिफ्रेन्ट मेटेरियल्स प्रोड्युस बाई सेल, स्पेसली इआर इन्डोप्लाज्मिक रेटिकुलमले डिफ्रेन्ट मेटेरियल्सहरू सिन्थेसाइज गर्छ। त्यो सिन्थेसाइज गरेको मेटेरियललाई यसले कलेक्सन गर्ने काम गर्छ। जस्तै कि अघि मैले फिगरमा यहाँलाई देखाइरहेको थिएँ, भेसिकल्समा सामानहरू हुन्छ भनेको थिएँ मैले। भेसिकल्सहरू इआरले प्रोड्युस गर्छ अनि त्यो भेसिकल्सहरूभित्र इआरले डिफ्रेन्ट टाइप अफ मेटेरियल्सहरू हालेर पठाएको हुन्छ। त्यसलाई पहिला कलेक्सन गर्नु पर्यो अनि त्यहाँभित्र अब भेसिकल्स नै फ्युज भएर ब्याग बन्छ। अघि मैले बताइसकेको छ, त्यो भेसिकल फ्युज भएर ब्याग अथवा सिस्टर नै बन्दाखेरि भेसिकल्समा कलेक्सन भएको सामान अब ब्यागभित्र पुग्छ। द्याट्स वाइ सो दिस सिस्टर्न हेल्प्स इन द स्टोरेज। अब त्यहाँभित्र पुगिसकेपछि अब त्यो यदि मोडिफाई हुनुपर्ने छ, केही चेन्ज गर्नुपर्ने छ, त्यो स्टोर भएको मेटेरियललाई पनि त्यहाँ मोडिफिकेसनको काम पनि हुन्छ। केमिकली द सब्सटेन्स विच आर स्टोर्ड इनसाइड द ब्याग आर मोडिफाइड एन्ड द रियल मेटेरियल्स आर प्रोड्युस्ड विच आर रिक्वायर्ड टु द डिफ्रेन्ट पार्ट्स अफ द सेल्स। सो मोडिफिकेसनको काम पनि हुन्छ। अनि प्याकिङ, लास्टमा व्हेन द मेटेरियल्स आर रेडी or when they are modified, then these materials are packed in a structure known as the Golgi vacuoles, जुन अघि मैले देखाइसकेको छ। र फाइनली विथ द हेल्प अफ Golgi vacuoles this transportation of the cellular materials takes place। सो दिस इज द फङ्सन अफ द गोल्गी बडी। जस्तै कि मैले सुरुमा भनेको थिएँ, ल्याउने काम भनेको भेसिकल्सहरूले गर्छ। अघि मैले देखाएको स्ट्रक्चर्सहरू, यही स्ट्रक्चर फ्युज भएर यसरी एउटा ब्याग जस्तो स्ट्रक्चर बन्छ। यसलाई हामीले सिस्टर्नी भनेको थियो, यसरी सिस्टर्नी भन्छ। अनि ह्यान्ड ब्याग लाइक स्ट्रक्चर हुन्छ। लास्टमा गएर चाहिँ अनि फेरि यसरी गोल्गी भ्याकुल्सहरू बन्ने गर्दछ। सो 3 मेन पार्ट्सहरू भनेको यिनीहरू नै हो। सो द मेटेरियल्स आर कलेक्टेड बाई दिस भेसिकल्स। After collection, these are storage in this bag known as cistern. The materials are stored in this bag. This is what cistern. And the materials stored inside this bag are modified, chemically modified. And then finally, the materials which are modified inside this bag are packed in a Golgi vacuoles. यो ब्यागको साइडबाट यसरी एक्सटेन्सन भएर Golgi vacuolesहरु बन्छ. Now the materials which are modified inside this bag are transported in this Golgi vacuoles, and the Golgi vacuoles are detached from this bag, and finally when the materials are stored inside this Golgi vacuoles, these are transported to different parts. So this is the main function of in Golgi bodies. Helps in collection, storage, modification, packing, and transportation of cell material. That's why it is also called commonly known as packaging cell organelles. Packaging cell organelles. Golgi body like packaging cell organelles. Why? Because this organelles are responsible for packing the substances prepared inside the cell. It is also known as traffic of the cell, also known as traffic of the cell. So why it is called traffic of the cell भन्ने कुरा पनि आउन सक्छ, किनभने एन्डोप्लाज्मिक रेटिकुलमले सामानहरु पठाउँछ भने मैले जस्तै कि मानिलियो यो ER भयो, सपोज ER, यो पोर्सन अफ द ER, यो ER को टुप्पाबाट नि यसरी भेसिकल्सहरु बन्ने गर्छ, डिट्याच भएर सानो बबल्स जस्तो भएर भेसिकल्सहरु निक्लिन्छ. यो ER को सामान अब भेसिकल्समा आयो, भेसिकल्सबाट अब यो ब्यागमा आयो, ब्यागबाट भ्याक्युलमा गयो, Golgi vacuole. So ER को सामान एकैचोटी जहाँ जानुपर्ने हो त्यहाँ जाँदैन. सपोज यो ER हो, पहिला नि तिनीहरु त्यो सामानहरु चाहिँ Golgi बडीमा आउँदै रहेछ, अनि त्यहाँनेरि मोडिफाइड हुन्छ अनि प्याक हुन्छ. सो एकैचोटी सामानहरुलाई अथवा सेलले बनाएको जति मेटेरियल्सहरु हुन्छ, these are not transported in the raw form. They are first collected, they are then stored temporarily, then what, they are purified or they are modified, then only transportation occurs. That's why it helps in holding the materials temporarily. So without transporting materials directly to the area where it is required, first they are treated and they are modified, and then only transportation occurs. That's why it functions like a traffic. It helps in holding the materials. It helps in the storage of the materials temporarily. So it helps to reduce the overcrowding of the molecules, because the molecules which are stored inside this bag are transported only when it is required. Otherwise, they are kept inside this bag. That's why it helps to minimize the overcrowding of the molecules. That's why it's also called traffic of the cell. So Golgi body also helps in the secretion of hormones. Different type of hormones are produced by cell, and especially these Golgi bodies are responsible for secretion of the different type of hormones, like sex hormone, testosterone, or the progesterone. These hormones are produced by Golgi body of the cells. Likewise, a Golgi body also helps in the preparation of cell plate and the primary lysosomes. Helps in the synthesis of primary lysosomes and cell plate. यो फंक्सन हामीले इन्डोप्लाज्मिक रेटिकुलममा पनि भेट्ने गर्छौं. इन्डोप्लाज्मिक रेटिकुलमले पनि यही काम गर्छ, यो दुईटै काम गर्छ, र यहाँ मैले Golgi बडी हामीले लेखिरहेको छु, Golgi बडीले पनि यही काम गर्छ. जस्तै कि अर्को एउटा कमन फंक्सन छ ER सँग. So also helps in repairing of cell membrane. जस्तै कि मैले यो फंक्सन पनि मैले अघि नै यहाँहरुलाई बताइसकेको छु एन्डोप्लाज्मिक रेटिकुलम. So these three functions, preparation means repairing of the cell membrane, synthesis of the primary lysosome, and the cell plate. These three functions are similar to endoplasmic reticulum. यो Golgi बडीले पनि गर्छ, endoplasmic reticulum ले पनि गर्छ. त्यसबाहेक Golgi बडी Also helps in the secretion of the different type of enzymes. Enzyme secretion help गर्छ. यस्तो थुप्रै फंक्सन्सहरु हामी लेख्न सक्छौं. Helps in enzyme secretion, helps in enzyme secretion. Also helps in the formation of sperms. A chromosome of the sperm is formed by sperm को एउटा टाउको जस्तो हुन्छ, head of the sperm. This is formed by the Golgi body. So these are the main functions of the Golgi body. The main function is this. There are so many other functions of it, but here I have shown only some important functions. And out of these different functions, this is the main function. It helps in collection, storage, modification, packing, and the transportation of cellular materials. अब मैले यहाँलाई अघि बताइसकेँ सेल थ्योरी was the first theory regarding the structure and the functions of the cell. त्यो अलिक पुरानो थ्योरी भयो 1839 AD को कुरा हो. सो त्यो भन्दा पछाडी अरु धेरै सेलको बारेमा नयाँ नयाँ इन्फर्मेसनहरु पत्ता लाग्यो अथवा नयाँ नयाँ कुराहरु पनि पत्ता लाग्यो जुन सेल थ्योरीले मेन्सन गर्न सकेको थिएन तर पाइन्छ. त्यस्तो स्ट्रक्चर जुन सेल थ्योरीले भनेको थिएन त्यो सेल थ्योरीले भने भन्दा पनि नयाँ स्ट्रक्चर्सहरु पनि अथवा नयाँ कुराहरु पनि पत्ता लाग्यो जसलाई हामी आज एक्सेप्सन अफ सेल थ्योरी भन्ने गर्छौं. केही पोइन्ट्सहरु म यहाँलाई राख्छु. जस्तो कि सेल थ्योरीले के भन्छ भन्दाखेरि हरेक सेल भित्र एउटा न्यूक्लियस हुनुपर्छ भन्छ. तर के अर्गानिजम पछाडी यस्तो पत्ता लाग्यो जसको भित्र न्यूक्लियस ठ्याक्कै देखिँदैन. Where the distinct nucleus or the definite nucleus is absent. For example, in bacteria. त्यो एउटा एक्सेप्सन भयो. जसलाई हामी यसरी लेखौं. Bacteria lacks distinct nucleus in the cell. एउटा ब्याक्टेरिया मात्रै हैन अर्को एउटा साइनोब्याक्टेरियाको पनि हुँदैन जसलाई हामी प्रोकार्योट्स भन्छौं. आज प्रोकार्योट्स ब्याक्टेरिया साइनोब्याक्टेरिया पनि हुन सक्छ. जस्तो कि मैले साइनोब्याक्टेरिया पनि लेखेँ. यो पनि एक्सेप्सन भयो सेल थ्योरीको लागि. Bacteria, cyanobacteria, these organisms lacks distinct nucleus in their cell. These organisms are called prokaryotes. So cell theory ले के भन्थ्यो भने सेल भएपछि न्यूक्लियस हुनुपर्छ भन्थ्यो तर यी अर्गानिजमहरुमा न्यूक्लियस डिस्टिंक्ट हुँदैन. त्यस्तै कुनै अर्गानिजम चाहिँ यस्तो पनि पत्ता लाग्यो जसमा एउटा भन्दा बढी न्यूक्लियस हुन्छ जुन सेल थ्योरीले भनेको थिएन. सेल थ्योरीले एउटा न्यूक्लियस हुन्छ भनेको थियो. सो some organisms like म्युकर जसलाई हामी ढुसी भन्छौं. म्युकर भयो अथवा राइजोपस पनि भन्न सक्छौं. एउटा एल्गी छ भौचेरिया. यो चाहिँ एल्गी हो. यो दुईटा चाहिँ फंगस हो. यो एउटा एल्गी हो. Some organisms like a म्युकर, राइजोपस, भौचेरिया bear more than one nucleus. जसलाई हामी मल्टिन्युक्लिएट भन्छौं. मल्टिन्युक्लिएट यस्तो अर्गानिजम पनि पत्ता लाग्यो जसमा एउटा भन्दा धेरै न्यूक्लियस छ. फर एक्जाम्पल मैले लेखेँ म्युकर, राइजोपस, भौचेरिया. दिस प्लान्ट्स एक्चुअली these are the plants which bear more than one nucleus. So this type of plants are also known as the multinucleate. यिनीहरुको सेलमा हेर्यो भने एउटा भन्दा धेरै न्यूक्लियस हुन्छ. सो दिस इज अनदर एक्सेप्सन्स. अर्को एउटा हामी भाइरसलाई पनि एक्सेप्सनको रूपमा लिन सक्छौं कि भाइरसले घरि लिभिङ क्यारेक्टर देखाउँछ घरि नन लिभिङ क्यारेक्टर्सहरु देखापर्छ. त्यसकारण भाइरस के हो भन्ने कुरा भाइरस लाइक अर्गानिजमको बारेमा पनि सेल थ्योरीले केही कुराहरु बताउन सकेन. सो जसको भित्र न्यूक्लियस त के अरु सेलका अरु मेटेरियल्सहरु पनि हुँदैन. सो भाइरस which is living as well as non-living depending upon the situation do not possess any character which is found inside the cell except DNA or RNA. So virus यसलाई यसरी लेखौं. virus shows both living and non-living character. Which was not mentioned in the points of cell theory. Cell theory मा यस्तो कुराहरुको बारेमा कुनै चर्चा भएन. That's why all these are the some points of what exception of the cell theory. यसलाई हामी drawbacks of cell theory भन्न पनि सक्छौं. Drawbacks भनेको exceptions भयो. drawbacks. Drawbacks of cell theory or exception of cell theory. So, I'll exception of cell theory. So, now I'm going to talk about this ribosomes. What is ribosome? What are the types of the different structures of the ribosomes and their functions? यसको बारेमा हामी कुरा गर्न गइरहेका छौं. So, ribosome चाहिँ यस्तो खालको सेल अर्गेनेल्स हो जुन सबैभन्दा सानो हुन्छ. So, it is the smallest cell organelles, and another very interesting thing is that it doesn't have any membrane around it. This is membraneless. यो भन्दा अगाडि पढेकोमा हामीले चर्चा गर्यौं कि कुनै सेल अर्गेनेल्समा दुईटा membrane हुन्छ, कभरिङ हुन्छ, कुनैमा एउटा हुन्छ, but this is membraneless and the smallest cell organelles, and you cannot see ribosomes with the help of compound microscope. So we need to use electron microscope if you want to see the structure of ribosome. So it is very small inside, the smallest cell organelles. Okay, यो कुरालाई म यहाँ point wise राख्दैछु. So ribosome, number one, it is the smallest cell organelle, and that's why it is electron microscopic. Electron microscopic means it can be seen only with the help of electron microscope. Electron microscope means is very much powerful microscope which can magnify objects more than compound microscope. So with the help of this microscope, electron microscope, we can see ribosome. Otherwise, the normal microscope that we usually use in lab cannot show these ribosomes. So it is the smallest cell organelle. Number one, it is membraneless. Another very important character of this cell organelle, it is membraneless. No covering around this ribosome. So it is colloidal in nature. It's a substance without any covering. It is another very important thing you should know about the ribosome is that it is universal cell organelles. It is found in all types of cells. So most of the cell organelles are found only in the eukaryotic cell. Otherwise, cell organelles are absent in prokaryotic cell. But this ribosome is found in both prokaryotic as well as in the eukaryotic cell. That's why it is called universal cell organelles. Universal cell organelles. So it means found in both prokaryotes and eukaryotes. So another. So ribosome is the structure which floats freely in the cytoplasm. This is also very important to notice that where ribosome is found inside the cell. It is found in cytoplasm in a free-floating condition, but also found within cell organelles. That's why this ribosome is also called organelle within organelles. Why? Because it is not found only in the cytoplasm, but also inside the cell organelles. Like within mitochondria or within the chloroplast, if you see the internal structure of mitochondria chloroplast, then you can see ribosomes of 70S type. Means it is also found within the other cell organelles like mitochondria and chloroplast, but also found in the cytoplasm. So it's organelles organelle within. So it is called organelle within organelles. Why? Because it is found within the organelle also, but also found in the cytoplasm. Let's not forget that it is not found in cytoplasm. It is also found in cytoplasm. Another interesting thing is that it is not only found in the cytoplasm, but it is also found within the cell organelles. That's why it is called organelles within organelles. So, while discussing the structure of mitochondria and chloroplast, we discussed that the ribosome is also found within the mitochondria and chloroplast. So, यो cell organelles, ribosome चाहिँ खाली साइटोप्लाज्ममा मात्रै पाइँदैन, सेल organelles भित्र पनि पाइन्छ. जस्तो हामीले कुरा गरिसकेका छौँ, माइटोकन्ड्रिया भित्र 70S टाइप अफ राइबोसोम हुन्छ, त्यस्तै क्लोरोप्लास्ट भित्र पनि हुन्छ, तर साइटोप्लाज्ममा पनि हुन्छ. Found freely floating in the cytoplasm as well. साइटोप्लाज्ममा पनि पाइन्छ, धेरै चाहिँ साइटोप्लाज्ममा पनि पाइन्छ, यदि सेल अर्गेनल्स छ भने त्यहाँभित्र पनि पाइन्छ. So another important points of, or the important, let's say, information about the ribosome is that it is made by two important chemicals. Chemically, ribosome is made up of rRNA, also called ribosomal RNA, and protein. So, if you are asked what makes the structure of ribosome, the answer is very simple. Ribosome is made by these two important components. One is rRNA and protein. So, chemically, ribosome is a nucleoprotein. So, you should know the meaning of nucleoprotein. What is the meaning of nucleoprotein? Ribosome is a nucleoprotein chemically. Why? Because it is made of nucleic acid and protein. Which type of the nucleic acid is used? rRNA. The RNA is a nucleic acid, ribonucleic acid. So, nucleic acid and protein makes the structure of the ribosome. That's why ribosome is a nucleoprotein made by nucleic acid, RNA and protein. That's why it is kind of chemicals. So, there are types of ribosome. There are two types of ribosome. One is 70S and another is 80S. There are two types of ribosomes, 70S and 80S, based on the speed of ribosomes. So, speed of ribosomes differs according to the size. So, what is the meaning of 70S and what is the meaning of 80S? दुई खालको हुँदो रहेछ राइबोसोम, एउटा 70S टाइपको, एउटा 80S टाइपको. यो कुरा अगाडि नै हामीले कुरा गरिसकेका छ, 70-80. So now I'm going to talk in details about what is the meaning of 70 and 80 based on the size and the speed. दुईटा कुरा मैले यहाँ जोडे. राइबोसोमहरु फर एक्जाम्पल दुईटा साइजको हुँदो रहेछ. जस्तै कि मैले एउटा सेल बनाएँ यहाँनेर. लेट्स सपोज दिस one cell, let's say animal cell, this is cell membrane, and let's say this is what, let's say this is mitochondria. Mitochondria. राइबोसोम सबैभन्दा सानो भएको हुनाले हामी यस्तो बनाउँछौँ, सेल भित्र राइबोसोम बनाउनु पर्यो भने यस्तो बनाउँछौँ. लेट्स सपोज in this way ribosomes are freely floating in the cytoplasm, very smaller in size. And let's suppose this is mitochondria. Mitochondria भित्र पनि राइबोसोम हुन्छ भने त मैले त्यो राइबोसोमको साइज चाहिँ अलिक सानो हुन्छ. फर एक्जाम्पल here I have tried to make ribosomes of the smaller size. जस्तो कि यो पनि राइबोसोम नै हो मैले बनाएको, यो बाहिरको पनि राइबोसोम नै हो. यो बाहिरको राइबोसोम जुन साइटोप्लाज्ममा बनाएको छ मैले, त्यो अलिकति ठुलो साइजको बनाएको छ. यो माइटोकन्ड्रिया क्लोरोप्लास्ट भित्र हुने राइबोसोम अलिक सानो खालको हुन्छ. सो साइजको आधारमा दुईटा भयो. जब साइज फरक पर्छ अनि खेरि राइबोसोमको स्पिड पनि फरक पर्छ ड्युरिङ सेडिमेन्टेसन भन्ने एउटा प्रोसेस हुन्छ त्यहाँ त्यो सेडिमेन्टेसन प्रोसेसमा दुई खालको राइबोसोमको स्पिड फरक पर्छ जस्तो कि यसलाई मैले यसरी बताएँ यो 70s भनेको अलिकति स्मलर साइजको राइबोसोम हो 80s भनेको अलिकति ठुलो साइजको राइबोसोम यु सी द डिफरेन्स इन साइज सो दिस इज हाउ देयर आर टु टाइप्स अफ राइबोसोम वान इज 70 अनदर इज 80s सबै राइबोसोमको साइज एउटै हुँदो रहेनछ दुई खालको राइबोसोम हुँदो रहेछ एउटा अलिक सानो खालको एउटा अलिकति ठुलो खालको सो फाइनली म यहाँहरूलाई अब राइबोसोमको फङ्सनको बारेमा बताउँछु व्हाट इज द फङ्सन अफ राइबोसोम राइबोसोम यस्तो ठाउँ हो सेलभित्रको जहाँनेरि प्रोटिन बन्ने काम हुन्छ प्रोटिन कहाँ बन्छ कसैले सोध्यो भने सेलभित्र त सेलभित्र पनि कहाँ भन्ने एन्सर दिनु पर्यो भने इट इज द राइबोसोम सो राइबोसोम इज द साइट अफ प्रोटिन सिन्थेसिस it is the site of protein synthesis. The process of protein synthesis is also called translation. Protein बन्ने प्रोसेसलाई ट्रान्सलेसन भन्छ जस्तै कि राइबोसोमले प्रोटिन बनाउँछ भनेको होइन हामीले यहाँनिर झुकिनु हुँदैन सो इज नट द्याट द राइबोसोम मेक्स प्रोटिन Ribosome is the place where the protein synthesis occurs. And the proteins are formed by the help of or by the RNA. Protein के ले बनाउँछ भनेर भन्नु पर्यो भने चाहिँ RNA ले बनाउँछ भन्नुपर्छ कहाँ बन्छ भनेर भन्नु पर्यो भने चाहिँ राइबोसोममा बन्छ That's why it is the site of protein synthesis. It is the place inside the cell where translation process occurs. That's why it is commonly known as this ribosome is commonly known as protein factory. Protein factory भनेर पनि भन्ने गरिन्छ राइबोसोमलाई. Why? Because in this factory protein is synthesized. कसैलाई engine of the cell भनेर पनि भन्ने गरिएको छ. Also known as engine of the cell. अनि राइबोसोम भित्र प्रोटिन बन्छ अनि त्यो प्रोटिन चाहिँ अरु ठाउँमा युज हुन्छ राइबोसोमले आफूले पनि अलिकति युज गर्छ तर धेरै चाहिँ अरु डिफरेन्ट पार्ट्स अफ सेलमा युज हुन्छ त्यसकारण राइबोसोमले प्रोटिन बनाइसकेपछि त्यो प्रोटिनलाई केही समयसम्म स्टोर गरेर राख्ने काम पनि गर्छ स्टोर्स प्रोटिन temporarily. It also stores protein temporarily. So these are the functions of the protein. The main function is it is the site of protein synthesis. It is the site of translation process. So अब प्रोटिन बन्नु भनेको अनेक चीज बन्नु हो जस्तो कि हार्मोन बन्नु भनेको पनि बुझ्न सकिन्छ अथवा इन्जाइम बनाउँछ भनेर पनि हामी लेख्न सक्छौं राइबोसोमले इन्जाइम बनाउँछ भन्दा पनि ठीक हुन्छ किन भन्दाखेरि enzymes are also specific type of proteins. राइबोसोमले हार्मोन बनाउँछ भन्दा पनि ठिकै हुन्छ. Why? Because some hormones are also specific type of proteins. So in this way, so राइबोसोमले प्रोटिन बनाउँछ डिफरेन्ट टाइप अफ प्रोटिन्सहरु हुन्छ जो त्यो हार्मोन पनि हुन सक्छ इन्जाइम पनि हुन सक्छ. So not only for the cell where the ribosomes are found, but it also ribosome also prepare protein for extracellular use. यसरी लेखौं also prepare proteins for extracellular use. आफ्नो सेलको लागि मात्रै हैन सेलदेखि बाहिर बनाउनु पर्ने प्रोटिनहरु पनि यही राइबोसोममा बन्छ. अल्सो प्रिपेयर्स भनेको मैले अघि बताइसके यहाँ झुकिनु भएन. बनाउने चाहिँ एक्चुअली आरएनए ले हो तर कहाँ बनाउँछ भन्दाखेरि राइबोसोममा बनाउँछ. सो इन्डोप्लाज्मिक रेटिकुलमको सर्फेसमा जुन राइबोसोम हुन्छ त्यो राइबोसोमले प्रोटिन बनाएर कहिलेकाहीँ त्यो प्रोटिन चाहिँ बाहिर सेल बाहिरको लागि पनि काम लाग्न सक्छ. So they are transported outside the cell. So in this way, for extracellular use also, this ribosome is the structure where the proteins are formed. त्यहाँ भएको प्रोटिनले बाहिरतिर पनि काम लाग्छ भन्न खोजेको. सो यसरी हामी राइबोसोमको फंक्सन्सहरुलाई समराइज गर्न सक्छौं. So this is the most important, it is site of protein synthesis.